Hello, welcome to this lecture video. So today we are going to consider still discussion on frequency measures. So in our topic on frequency measures, we are done with the ratio except that we end up with the examples on application of ratio. So we have here the given example. So it is one of the particular ratio used in epidemiology. It is the death to case ratio. So let's have this example. So we have here the number of deaths and the number of the new cases of tuberculosis. So what you need to do now is simply to divide the values. So the number of deaths is 802. The number of new cases is 15,075. So just to show that in a separate, let's consider paint. But of course, we still need to see the values here. So we have 802 deaths and 15,075 new cases. So it can be that we can multiply or simply let us just copy that value here. So 802 and this is the number of deaths and 15,075 new cases. Okay. So what we need to do is it can be dividing 802 to 15,075. So if we will divide that, so using the calculator, so let us use the calculator here so that you can see the computation. So it is 802 divided by 15,075. And the answer is equal to 0.053. So instead of dealing with this very low number, we can actually multiply this by 100 and this will give us 5.3. 5.3. So what is the meaning of this value now? Now, if we are also going to consider 15,075 over 802, so using again our calculator, so let us compute for that. 15,075 divided by 802. The result is 18.79 or this can be written as 18.8. So let us go back. So what is, if we are going to interpret this as 5.3 or 18.8, so it doesn't matter. So here we know that for every one person or one death case, so there is one death case per 18.8 new cases. While if we are going to use 5.3, this is the number of deaths. So 5.3 deaths per 100 cases. So it is per 100 cases simply because we multiply it by 100. Because if it is 0.053, so we will state it that there is 0.053 deaths per case. But since we multiply it by 100 so that it's better to, or it's easily understood. So it's a 5.3 deaths per 100 cases, or it can be 18.1 death for every 18.8 new cases. So that is how to use rather ratio in computing for this. And since the concern is death and new cases, that's why this is an example of, let's go back to our slide, death to case ratio. So the number of deaths and the number of new cases. So that's the one that, related to this. So it's death to rate cases. Now, if we are going to move to another topic, and that is measure another frequency commonly used frequency measure, that's the proportion in comparison to ratio. For ratio, we can actually use any variable. So as mentioned, just like with the previous example, the example of death to case ratio, the number of death, the number of new cases, and also to other previous examples on the number of clinics with that of the number of persons in a city or people in the city, and also same variables like the number of what we call this. So let us just go back to that so that we can recall, and you can also recall for that given example. So we have here for the diabetic men, non-diabetic men, diabetic women, non-diabetic women, and so on and so forth. So it can also be a ratio of male, female, and all other cases. So the variables can vary. But for proportion, if we are going to use proportion, the denominator must be the same variable with our numerator. So if our case, for instance, is diabetic men, then our denominator must be the total number of diabetic men. So this is closely related with what I asked you before to compute the percent value. So however, the 10 that raised to n is strictly 10 raised to n is equal to 2, because when we talk about percent, that is 100. So it's multiplied by 100. So let us take, for instance, this example, calculating a proportion. So it's a proportion of men who were diabetic. So for the numerator, it is 189 diabetic men. And if you noticed here, our denominator is also the total number of men. So it still considers now non-diabetic men. So if we are going to compare this with the ratio, in the ratio, what we use is diabetic men and non-diabetic men. But here, it's the total. So what we need to do is to add the diabetic men and non-diabetic men for a total of 3,340. So 189 all over 3,340 multiplied by 100%, it is 5.66%. Or we also have here another example. So this example is about proportion of deaths of among men. So it is now also the numerator is the deaths in men. So regardless now whether they are diabetic or non-diabetic, because our case is death, then you have to consider both diabetic and non-diabetic. So there's a need to add the two. So the result is 911 deaths in men. Now, because of course, this is already the total number, we have to consider that our case here is the total number of deaths. So we have to add the total number of deaths of men and women, diabetic and non-diabetic, for us to come up with the total deaths. So it is 911 all over 1,490. For it is 60.98, which is equal to 61%. Okay. Now, what are the properties of proportion? So for the properties of the proportion, so we have the following. Proportions are commonly descriptive measures used in all fields. So in epidemiology, proportions are used most often as descriptive measures. For example, one could calculate the proportion of persons enrolled in a study among all those eligible. Participation, we call that as participation rate. So the proportion of children in a village vaccinated against measles, or the proportions of persons who develop illness among all passengers of cruise ships. So proportions are also used to describe the amount of disease. So what do we like to highlight here? So it is a measure used in all fields. It is most often used in the descriptive measure. So it describes the amount of deceased, so that can be attributed to a particular exposure. So an example of this is smoking and lung cancer. So we have an estimated value of 90% of the lung cancer cases that occur and are attributed to cigarette smoking. So in proportion, the numerator must be included in the denominator. So it is the numerator is a subset. It's a part of the denominator because the denominator is the total. And so as mentioned, numerator is a subset of the denominator. So proportion can be expressed as a fraction, it can be a decimal, or it can be a percent. So if you multiply it by 100%, it's already in percentage. So if we go back here, so just to emphasize, so for fraction, so we have this fraction 911 all over 1,494. Now for decimal, so 0.6098, and for percent, it is 60.98 or 61%. So it can also be written as percentage. Okay, let us move. Proportion can easily be converted to ratio. So if the numerator is the number of women, it's 179, for example. And the denominator is all the attendees, it is 341. The proportion of the clinic who are women is 179 all over 341, or 52%. So to convert a ratio, subtract the numerator from the denominator to get the number of clinic patients who are not women. So you can, of course, since as mentioned, in the relation to the given property that it is a subset, then if you will multiply now the case of, for example, the case, the numerator is that is the case of the women. So if you remove that in the total, so for example, the total is 341. So you know that the total number of men is 162, which means you can also compute now for the ratio of women to men. So how is that done? So we have here, so if you notice, this is the total 341. So less, this is the case of women. So if this is the women, then 162 is the female, this is the case of the male. So it means that 179 all over 162, or 1.1 to 1 female to male ratio, or you can also reverse that. So what is a specific type of epidemiologic proportion that is used? So we have the proportionate mortality. So if our concern now is what do you call this?